In addition to adding additional features to the circle class, we can also look at how we would extend that to handle additional shape classes. So if we look at the shapes.py file, not only do we have a circle class down here, but we've also decided that we need support for additional shapes like rectangles and triangles. And this is using a special technique called inheritance and polymorphism. So the idea is that although these shapes are different in terms of how you parameterize them and whatnot, fundamentally it's a shape, and you might want to do similar things with each of them, such as be able to get the area of the shape. So to start the implementation, we have up here at the top of the file a generic shape class. And this is serving as what's called a parent class to all of the specialized shape classes like rectangles, circles, etc. Now, we can't implement a get area method for a generic shape because we don't know how to compute the area for an arbitrary shape. All we can really say is that this is a method that should be implemented by all shape classes. So I should be able to get the area of a rectangle, get the area of a circle, etc. So I have a prototype implementation which raises a not implemented error to serve as a reminder that it needs to be overridden by a particular shape class like a rectangle. So now when I come down to a specific shape like the rectangle here, I have class rectangle, but in parentheses after rectangle I have in shape, and this is the signal to Python that rectangle should inherit the functionality of shape and then has the freedom to add, modify, extend that behavior. So a rectangle class can have a specific initialization method to parameterize the rectangle using the width and height and store that as attributes of the class. It can have a specialized string representation method that prints out the width and height, and it can also override or replace the generic getArea method that it inherits from the parent shape class and provide the specific implementation that's particular to a rectangle. And similarly, for a circle, I have specialized initialization, string representation, and getArea methods for the circle and also the rectangle as well. Now, if I start up Python, I'm going to import the shapes file so that I can have access to that, and remember that I can use the help method and scroll through and see what class methods are defined and see that each of my rectangle, circle, etc. have the appropriate initialization method and a getArea method that's specialized to the particular class. And where this setup is maybe typically used is maybe I'd like to actually have, instead of individual shapes, an entire container of shapes, maybe a list of shapes in this case. So I start off with a empty list, the square brackets, and then I go ahead and append to that. I maybe want to throw in a circle of a given size, and just to check out all of the code here, I'll go ahead and create a a triangle. So now I have shapes, and you see Python's actually really smart, and when it goes and tries to print out a list of classes, it's actually, when it goes to print out the individual elements of the list, it goes and finds the string representation methods for the circle, triangle, etc., and you get this little printout of the various shapes. And now I can go ahead and maybe throw in some more as well. Maybe I have another circle here, and just so the rectangle doesn't feel left out, I'll go ahead and add one of those as well. So now I have this container of various shapes, and I can access a particular shape. This is a circle with radius 1.4. I can call the getArea method for that. and it doesn't really matter what type of shape I'm dealing with. I know that all of my shapes implement the getArea method and have the appropriate implementation that's specialized to a given shape. And I can even do things like this, where I iterate over an entire container of shapes, and then for each one I can print out the area, and I don't even need to know whether it's a circle, rectangle, triangle, etc. I just know that because I've set up this generic parent shape class and specified that all my shape classes need to provide a getArea method, that's always going to work regardless of the types of methods that I have in my container. So it's gone through, and for each shape in my container, it's called the appropriate getArea method that's specialized to the circle, triangle, and rectangle in this case.